Good day, Philippines. Hello, Region 1. Aloha, San Carlinian learners. Airing live from the mango bamboo capital of the Philippines, San Carlos City. You're tuning in to CCN Broadcast Center, a virtual home of every SDO-SEC learner, where passion is the key. Learning paves the way. With our division mantra, developing creativity, maximizing versatility. This is your CCN Broadcast Center. CCN Broadcast Center, a virtual home of every SDO-SEC learner.
Good afternoon, learners! Welcome to another fun and meaningful learning experience in physical science. My name is Chikki V, Quevedo, and today let me walk you through another module, which is your Module 5, General Types of Intermolecular Forces. So, make sure you have the following before we start. First of all, your self-learning module. Second, your pen, and of course, a piece of paper so you can write down important notes during our discussion. For our most essential learning competency, describe the general types of intermolecular forces. And for our lesson objectives, by the end of the class, you should be able to describe the types of intermolecular forces present in substances and identify the types of intermolecular forces present between and among substances. So, to learn more effectively, remember to listen carefully, observe, so watch closely, focus on the details of the discussion, take notes as you should, and discuss at the end of the class with your classmates everything that you've learned from this class. Okay, so are you excited for a fun learning experience? So am I, so let's get this started. Okay, so today's science lesson will be all about the general types of intermolecular forces. Now, before we start, let's see what you already know about the topic. Let's play word cryptogram. So the mechanics of the game is very simple. All you have to do is unscramble the letters by placing the correct letter sequence in the boxes to come up with the correct answer for each number. Use the numbered boxes to complete the answer to the riddle at the end of the activity. Let's start. Number 1, we're looking at an 8-letter word. I know you know the answer to this, and you're right. This is molecule. Can you say something about molecule? What is a molecule? That's right. So it is an electrically neutral group of 2 or more atoms held together by chemical bonds. Very good, that's a molecule. Number 2, we have a 2-letter word. Correct, we have polar bonds. So a polar bond is a type of chemical bond where a pair of electrons is unequally shared between 2 atoms. Very good. Let's keep going. Number 3, we have another 2 words. And this is correct. We have lone pair. So what is a lone pair? A lone pair is an electron pair in the outermost shell of a molecule that is, of an atom that is not shared or bonded together with another atom. Okay, very good. That's a lone pair. And number 4, we have, correct, that is non-polar bond. So in this case, this is a type of chemical bond where 2 atoms share equally a pair of electrons. Okay, next, let's keep going. Number 5, this is a long word, but I know you know the answer. This is correct, electronegativity. So what is electronegativity? This is a tendency of an atom to attract electrons towards itself. Very good. Last one. This should be easy. We're looking at a 4-letter word. This is atom. And of course, it is the smallest unit of matter. Now, did you take note of the letters that correspond to different numbers? we're going to use those letters to answer our riddle. It shows the three-dimensional arrangement of bonding groups of atoms around a central atom. What's the answer? That's right. We're looking at molecular geometry. Okay, good job, dear learners. Give yourselves a warm round of applause for doing a job well done. Now we're ready to dive deeper into the general types of intermolecular forces. Now, to do that, let's watch a video of a gecko. Okay, but before that, so you're about to see a video of a gecko. What is a gecko? A gecko is a type of reptile. So reptiles are known to have long, dry, scaly skin. Okay, so they are known to lay eggs as well, and a gecko is a type of lizard. Now, in Tagalog or Filipino, ito yung tinatawag natin na butiki. Alright, so please observe carefully what's going on in the video and answer the question afterwards. Let's play the video again. All right. Okay, so actually what you're about to see is a video of a gecko scaling a vertical wall and hanging upside down from a ceiling. So the big question is, why can a gecko walk upside down on ceilings while humans cannot? How do geckos defy gravity? So here it goes. Here's the video. Great, okay. So as we have seen, the gecko scaled a vertical wall and hang upside down from a ceiling. So actually, the geckos use a very simple principle. But what principle is it? Let's start exploring the answers to these mind-boggling questions in the next activity. So this activity is called Mix to the Max. So this gives you a chance to look over the basics of what happens when certain substances are mixed together. So what dissolves, what do not, and what explains this phenomenon. Okay, so when substances are mixed together, some mix easily and some do not. But how can you tell? Try mixing these experiments at home and write your observations on your notebook. For your safety, please do wash your hands thoroughly right after performing this activity. But if you do not have the materials to perform this activity, let's watch the videos. Okay, so let's start with milk and sugar. Okay. So, let's try to play the video of the milk and sugar mixture. Please try the audience view. easily the sugar melts into the milk. Okay, so we see this phenomenon most of the time whenever we buy our favorite drink, which is milk tea, right? Okay, so there's no question to it. Milk and sugar does mix well together. All right, moving forward, we have another type of mixture, which is water and oil. So, I know even if I don't play the video first, you already can tell that water and oil don't mix. Okay, so whether we stir it very fast or very slow, even if we raise the temperature of the water and oil cannot mix together. Okay, and I know that you see this at your homes as well whenever you try to clean or to wash the dishes after a greasy meal, right? So water finds it really tough to wash away the grease or the oil. It's because they cannot mix. Okay, next, last one, we have vinegar and soy sauce. So what's your guess? Can they mix well? The answer is yes, most definitely. So vinegar and soy sauce have the same properties, so they mix well. And actually, our moms usually use this mixture to cook our favorite dish, which is adobo. Okay, so vinegar and soy sauce not only mix well, but they actually taste really good together. Okay, so well done, learners. That is for our activity, mix to the max. Okay, so what do these mixtures have to do with general types of intermolecular forces? So there are two kinds of forces or attractions that operate in a molecule. We have the intermolecular and intramolecular. Let's try to understand the difference. When we say intramolecular, these are forces that hold atoms together within a molecule. But when we say intermolecular, these are forces that exist between molecules. So simply put, when we say intramolecular, these are forces within a molecule. And when we say intermolecular, these are forces between molecules. Okay, now, what's the significance of intermolecular forces? Oh, please move over to the next slide. Okay, all right. So the significance of intermolecular forces are they're present to keep molecules together, giving rise to the different states of matter, which then exhibit their own bulk properties. So what are these bulk properties? We have melting points, boiling points, freezing points, density, viscosity, enthalpies of fusion and vaporization, among others. Okay, so without intermolecular forces, we would not have different phases of matter. Alright, now there are three general types of intermolecular forces, namely the van der Waals forces, ion dipole interaction, and the hydrogen bonding. Let's check the first type first. For the van der Waals forces, they're actually named after the Dutch chemist Johannes van der Waals, and these types of forces consist of dipole-dipole interaction, Dibel-Induced dipole interaction, and London dispersion forces. Let's discuss the dipole-dipole interaction first. For the dipole-dipole interaction, this occurs when the partially positive charged part of a molecule interacts with the partially negatively charged part of another molecule. So the prerequisite for this type of attraction to exist is partially charged ions. For example, the case of polar covalent bonds such as hydrogen chloride. So this is actually the strongest intermolecular force of attraction, and it will take a lot of effort to break off these bonds or these forces. Okay. Next, we have the Dibel-Induced dipole interaction. Now this type of attraction depends on the presence of polar molecules. Take note that the other molecule, the second molecule, does not have to be polar. Okay, so the partial charges present in the dipole causes polarization or distortion of the electron distribution of the second molecule. So as a result of the polarization and distortion, the second molecule now acquires a region of partial positive and negative charges. Therefore, it started as a non-polar molecule, now it ends up as a polar one. This induced dipole will be then attracted to the original polar molecules, resulting to Dibel-Induced Dipole Interaction. So this is an illustration of a Dipole-Induced Dipole interaction between a dipole and a water molecule. Okay, next we have the third one under the van der Waals forces. We have London dispersion forces. These forces are named after the German physicist Fritz London. Now this is the weakest of the intermolecular forces. Now, given the fact that it is the weakest, it exists in all types of molecules, whether it's ionic, covalent, polar, or non-polar. So the more electrons a molecule has, the higher or the stronger the London dispersion forces are. For example, bromine here. Bromine has more electrons than chlorine, which means it will have stronger London dispersion forces compared to chlorine. As a result, it will have a higher boiling point than chlorine. Okay. So that is the first general type of intermolecular force. Let's go to the second one. We have, this one. So the van der Waals forces is a catch-all term. Although non-polar molecules are by no means uncommon, many kinds of molecules possess permanent dipole moments. So liquids and solids composed of these species will be held together by a combination of dipole-dipole, Dibel-Induced Dipole Interaction, and London dispersion forces. These weaker forces are known collectively as van der Waals forces. Okay, moving on to the second one, we have the ion-dipole interaction. Now, this interaction results from the attraction between either a cation or an anion with permanent polar molecules. So, as its name goes, ion-dipole, it is an interaction between a charged ion and a molecule that has a dipole. So the ions will be attracted to the opposite charges present in the dipole, resulting to this type of attraction. So this one is commonly found in solutions. So this is an example of an ion-dipole interaction. We can see here a sodium ion and oxygen atoms are attracted to each other, while the sodium and hydrogen are repelling each other. Okay, moving forward, we have the third and last general type of intermolecular forces. We have the hydrogen bonding. So hydrogen bonding is a special kind of dipole-dipole interaction. Take note of that. And it occurs specifically when a hydrogen atom bonds together with an atom of either an oxygen, nitrogen, or fluorine. Okay. So what happens here is that the partially positive end of hydrogen is attracted to the partially negative end of the oxygen, nitrogen, or fluorine atom of the neighboring molecule. So, given that fact, this is a relatively strong force of interaction. So it means a considerable amount of energy will be needed to break off these hydrogen bonds. This is the explanation why some compounds have high boiling points and high melting points. So hydrogen bonding also plays a very important role in biology. For example, hydrogen bonds are responsible for holding nucleotide bases together in DNA and RNA. Alright, so going back to the gecko video, what is the answer to the question, how do geckos defy gravity? Okay, let's play. Alright, so the gecko uses a very simple principle. What is this principle? That positive and negative charges attract. Okay, so in this case, the gecko uses the van der Waals forces to attach itself to the wall. And not just the gecko actually, also the spiders and the other types of lizards that can scale a vertical wall and hang upside down from a ceiling. Alright. Okay, so now let's have a really quick quiz and let's see what you learned after discussing all these concepts. So please answer this question with yes or no. This statement with yes or no. Intermolecular forces are actually bonds between molecules. Yes or no? The answer is no. Okay, very good. So despite the use of the word bond, keep in mind that hydrogen bonds are intermolecular forces, okay? Not intramolecular forces. So they're very different. Remember, intramolecular forces exist within a molecule, they are bonds, but intermolecular forces, they exist between molecules, they are forces. Okay, next, statement number 2. When water evaporates, the water molecules break apart into hydrogen and oxygen. Yes or no? The answer is no. Very good. Okay, so a molecule of water remains a molecule of water whether it's in its solid, liquid, or gaseous state. Water does not break apart into hydrogen and oxygen atoms. Okay, now did you have fun learning? I hope you did. And now it's time for our seed work. So in here, let's identify the different intermolecular forces present in some molecules. The first one is hydrogen sulfide. What are the forces present in here? We have okay, so of course we have the London dispersion force. By default, this is present in every compound because it's the weakest form of force of attraction. Okay, so aside from London dispersion force, we also have the dipole-dipole attraction. Number 2, we have the methanol. So right off the bat, you can already tell, right? Okay, very good. We have the London dispersion force, of course, the dipole-dipole attraction, and the hydrogen bonding. We can see the hydrogen atom bonded to the oxygen atom. Okay, next one, we have the ethane. And your answer is? Alright, so we have London dispersion forces because it's a non-polar covalent compound and no other intermolecular attractions. Very good. Kindly give yourselves a tap on the back because you did great in that activity. Now, it is module time. So please grab your modules, your self-learning modules, and turn to page 7. So in this activity, you have to use the illustrations. So using the illustrations below, describe what happens in each of the attractions between substances by completing each sentence with correct words. Tell what kind of attractive forces keep the substances together. So you have 1 minute to answer this part of your module. Your 1 minute starts now. Alright, good job on answering that part of your module. Please make sure that you submit your module to your science teachers. Okay, now it is time for a quiz. Let's put your knowledge to the test and try your best to get a perfect score. Are you ready? Let's go. So let's have, for the first part, let's have enumeration, okay? So, please list the 3 general types of intermolecular forces of attraction. Please write them down on your notebook. Okay, you can also comment on the comment section, your answers. Okay, so of course we have, number 1, the van der Waals forces, 2, the ion-dipole interaction, and 3, the hydrogen bonding. Very good. Next, for part 2, let's have a 5-item multiple choice. For the first one, please complete this statement. Ion-dipole interaction results from the Good job. Attraction between an ion and a polar molecule. Remember the name ion-dipole? It's the interaction between a charged ion and a molecule that has a dipole. Very good. Number 2. Please complete another statement. Hydrogen bonding forms when the substances involved are polar and have molecules with That's right. Okay, we have hydrogen atoms attached to oxygen, nitrogen, or fluorine. Okay, let's keep going. Number 3. Which of the following species is capable of hydrogen bonding among themselves? Right off the bat, you can already tell, right? We have letter C, methanol. Okay. Number 4, why are dispersion forces high in molecules with a great number of electrons? Excellent choice. That's because the electron distribution of big molecules is easily polarized. Very good. Okay, last one. How does dipole-dipole interaction happen? And your answers are right. It's letter D. The negative and positive ends of one polar molecule align themselves to the positive and negative ends of another polar molecule, and they attract each other. Good job! Okay, that was amazing, dear learners. Please give yourselves a warm round of applause for doing such a great job. Okay, now for your homework, you can either screenshot this part or copy it on your notebook. So let's apply what you've learned in real life. So this is an essay writing. Let's look into a situation that will help us realize the advantage of fully understanding the intermolecular forces concepts. So the situation is this. Storage of different substances at home needs careful attention. Alcohol, acetone, and hairsprays, even gasoline, should be taken care of to avoid fire. Where should these substances be stored? Why do we need extra precaution in keeping them at home? Relate your answers to intermolecular forces. Please be guided accordingly by the following rubrics. Content is worth 20 points. Organization, 15 points. Mechanics, 15 points for a total of 50 points. Okay. All right. So thank you very much. That was a blast, dear learners. I hope you learned a lot while still having fun and, having a very meaningful learning experience today in our science class. Again, you are highly encouraged to discuss everything that you've learned with your classmates at the end of our session. Okay, and please don't forget to submit your modules, and I hope you always remember the concepts that we have tackled. This has been Teacher Chikki, leaving you with a quote to live by. There is no force more powerful than the mindset of a person who never gives up. Thank you very much and enjoy the rest of the day. Bye!
Good day, Philippines. Hello, Region 1. Aloha, San Carlinian learners. Airing live from the mango bamboo capital of the Philippines, San Carlos City. You're tuning into CCN Broadcast Center, a virtual home of every SDO-SEC learner, where passion is the key. Learning paves the way. With our division mantra, developing creativity, maximizing versatility. This is your CCN Broadcast Center. CCN Broadcast Center, a virtual home of every SDO-SEC learner.